Welcome back to the next one. We have accuracy, precision of instruments, and error in disputes. So, what is error? We are taking any one readings, that is called measured value, and it has original value, that is called, we are saying that true value. So, assume that we are going to measure the length of the wire, it becomes 10.2 centimeter. That is the true value. But if you measure, that will give as if that 10.1. So there is some difference, right? So that will give the error, right? And what is called accuracy. So how much closer we are very closer to that true value, right? That will give accuracy. Precision is telling about the resolution, right? Let me move on to the topic. Error. Error is measuring instruments contains some uncertainty, right? Uncertainty. So this is theoretically, but practically what we are doing, the difference between true value and measured value, that will give error. And the second one is accuracy. How closer to the measured value, how the measured value is closer to that true value, that will give about accuracy. And the third one is precision. The resolution or the limit the quantity is measured. So how far we are make a resolution or limit to that measured quantity, right? And for your better understanding, here I wrote for error, accuracy and precision. The true value is 3.678 centimeter. The first observer measured value is 3.5 centimeter. Its instrument position is 0.1 centimeter. And the second observer measured value is 3.38 centimeter and precision value is 0.01 centimeter. So which one is more accuracy? Either this one or this one? Of course, the first person has more accuracy but less resolution, right? Less precision. But when compared to the second person, he has more precision, but we have some accuracy is missing in the second observer, right? So this is a very good understanding about error, accuracy and precision, and we can move on to the error. Yeah, next one we are moving on to the types of errors. So we have different types of errors. We have, as the first one, we will have systematic errors, and the second one is we have constant errors, random errors, least count errors, gross errors or mistakes, and apart from that we have absolute error, relative error, and we have percentage error also. And we will have some more things. We have combination of errors also we will have. So first of all, we move on to the first one. We will go for constant errors. What is called constant errors? The errors which affect each observation by the same amount. Whenever if you are doing in the experiment, that will give the same amount of error, that will give constant errors. So how we can rectify this problem is, we can go for number of different methods or apparatus or technique we can use for to sort out this constant errors. And the next one is we have systematic errors. So what is systematic errors? The errors which tend to occur in one direction. So one direction it will give, right? So that will give systematic errors. In the systematic errors, we will have the first one, instrumental errors. So what is instrumental errors? It is occurs due to inbuilt. By inbuilt, we will have some defect. So that is called instrumental defect. And a very good example, we can say that in vernier calipers, the zero mark of vernier scale may not coincide with the zero of the main scale. That is a very good example for instrumental error. And how we can avoid these kind of errors, instrumental errors, in the sense, better we can go and use different instruments, or we can use different methods to avoid to rectify the instrumental problem errors. And move on to the next one, the imperfection in experimental technique, imperfection in crystal technique. So it is due to the limitation of experimental procedure. From the experimental procedure itself, you have some limitation for imperfection in experimental technique. So how, in a sense, if you are using thermometer to determine our body temperature under our armpit, that will give lower temperature than its actual size, actual temperature. That is a very good example for imperfection in experimental defects. How? And the next one is personal error. What is called personal error? It is arises due to individual bias or the lack of proper settings of apparatus or the individual carelessness in taking observation. So suppose if you are going to measure vernier caliper or screw catch, your eye should be exactly straight to that readings. If you are inclined, that will give some personal errors. So how we can avoid these kind of personal errors? In the sense, we can repeat the measurement with different persons or removing the personal bias as far as possible. And very good example for personal error, when an observer by habit holds his head towards the right while taking reading, he introduced parallax error, that is called a personal error. And the next one is we will have errors due to external causes. Suppose the temperature or pressure is varied, so that the errors occurs in that experiment. So in lower classes we may study the Ohm's law, right? That Ohm's law depends upon at constant temperature only we are saying, right? If temperature varied, errors occurs in that experiments. And moving on to the next one, random errors, right? Random errors. And what is called random errors? It occurs irregularly and at random. So it occurs irregularly and at random and in magnitude and direction. Both magnitude and direction will happen. So how to avoid these kind of random errors? We can go for arithmetic mean. Arithmetic mean means, so taking the readings of all the readings, sum of and divided by the total number of trials we have taken. And very good observation, if you are measuring a scale, a length of, by using a scale, you are going to measure the length of a wire. Each and every time you will get different values, right? So not exact centimeter. For example, 12.12 centimeter in the sense, next time you will get 12.1 centimeter, right? Similarly, you will get different values each and every time. That is called random errors. And the next one is least count. So what is called least count error? It is due to limitation imposed by the least count of the measuring instrument. So every measuring instrument will have the least count. So that least count impose some errors due to the limitation, right? So that is called least count errors. Very good example. What is called least count? The smallest division on the scale of the measuring instrument, that is called least count. The smallest division on the scale of the measuring instrument is called least count, right? And the next one is we have cross error or mistakes. It is due to either carelessness of the person or due to improper adjustments of the apparatus. Either the mistake will happen by human made or otherwise the improper adjustments of the apparatus. And moving on to the next one, absolute error. What is called absolute error? The magnitude of the difference. This is called difference, right? The difference between the true value of the quantity measured and the individual measured value. So here we have delta A1 is equal to A bar minus A1. A bar is the arithmetic mean value. That A bar is equal to A1 plus A2 plus up to AN divided by N. That is called arithmetic mean of A. So that will give absolute error. So and the next one here we have, right, that is called mean or final absolute error. So delta A bar is equal to sum of all those absolute errors. So within modulus delta A1 plus delta A2 plus up to delta AN divided by N, that will give the mean or the final absolute error. And the next one is we have relative error. What is called relative error? The arithmetic mean, what is called relative error? It is the absolute error, average of absolute error divided by arithmetic mean, right? So the ratio of mean absolute error to the true value. A bar is the true value, okay, of the measured quantity. That will give relative error. And what is called percentage error? So this relative error is going to be expressed in terms of percentage. That will give percentage error, right? So this relative error is expressed in terms of percentage. That will give percentage error, right? I hope you understand well. Thank you. See you in the next video. Just moving on to the combination of errors we have three different cases. Sum or difference, second one is product, and third one is power series. So sum means we have assume that the measured value will have true value plus error value, right? So A is equal to A plus or minus delta A, B is equal to B plus or minus delta B, and Z is equal to, we are going to sum up these two values. So Z is equal to A plus B. So Z plus or minus del Z is equal to A plus or minus del A plus B plus or minus del B. So we can take A and B as first. So A plus B, again you can take plus or minus delta A plus delta B. So what is A plus B? Z. So Z plus or minus del Z is equal to Z plus or minus del A plus del B. So here we have Z, here we have Z, here we have plus or minus, here we have plus or minus. Therefore del Z is equal to del A plus del B. So what is del A and del B? That is called absolute error. So how we can define the absolute error in the final result in the sum of absolute errors in the individual quantities. Again I can say the absolute error in the final result is the sum of absolute errors in the individual quantities. So these two are individual absolute errors, right? Similarly, you can go for difference, right, for your homework. And the product, the next one is Z is equal to A into B. Again we are going to substitute Z is equal to Z plus or minus del Z. A is equal to A plus or minus del A. B is equal to B plus or minus del B, delta B. So again we are going to multiply this component A into B, AB. So A into delta B, delta AB. Sorry, A into delta B, A into delta B. And delta A into B, B into delta A. And delta A into delta B, right? And this side we can, left side we can divide by Z, and right hand side we can divide by AB. Therefore it will give 1 plus or minus delta Z by Z, that is equal to, so this one becomes 1, and plus or minus delta B by B plus or minus delta A by A, because here we have A, here we have B. So if you are divided with AB, this term will be cancelled, only we will have B, and here we will have A, and plus or minus delta A by A, delta B by B, and delta A by A and delta B by B is very small. We can neglect, we can compare only these two terms. So 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A plus or minus delta B by B. So 1 plus or minus delta Z by Z is equal to 1 plus or minus, I am taking common, so delta A by A plus delta B by B. So here we have 1, here we have 1, here we have plus or minus, here we have plus or minus 1. Therefore delta Z by Z is equal to delta A by A plus delta B by B. So what is called delta A by delta A by A? What is called delta A by A? Relative error, right? Relative errors. So how we can define? So when two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multiplier. Again I am telling, when the two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multiplier. This is called relative errors, right? So we are adding the relative errors of two different quantities, sum of. This is sum of, plus sign, right? Plus sign we have, right? So that is called product rule, right? Similarly we go for power rule also. We are moving on to the third rule, the error in the power of quantity. So error in the power of quantity. So Z is equal to A to the power n. So what will happen? Z plus or minus del Z is equal to A plus or minus delta A to the power n. So I am taking A as common. So A bracket 1 plus or minus delta A by A, close the bracket, whole to the power n. So I can apply this power here. So A to the power n, 1 plus or minus delta A by A to the power n. And I can write this one as 1 plus n into delta A by A, because using binomial theorem, 1 plus x to the power n is equal to 1 plus nx when x equal to less than 1. This is a condition for binomial series. 1 plus x to the whole power n is equal to 1 plus nx, we can write when x is less than, very much less than 1. That condition we can write. What is x here? Delta A by A. Therefore I can write, so instead of that I can write 1 plus n into delta A by A. So Z plus or minus del Z is equal to Z into 1 plus n into delta A by A. So how it becomes Z? A power n, right? What is A power n? Z. So we can cancel over z by both sides. So divide by z on both sides. So 1 plus or minus del z by z is equal to 1 plus n into delta a by a. So we can cancel over both sides 1. Therefore delta z by z is equal to n into delta a by a. So what is delta a by a? It is called relative error. That is n times of relative error, right? So we can define that the relative error in a physical quantity raised to the power of k is the k times the relative error in the individual quantity. Again I can say the relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. I hope you understand well. Thank you. See you in the next video.